Data is the new oil is the phrase we have been hearing a lot these days, and any company or organization that wants to succeed in today's cutthroat business environment needs to have access to one of the most potent tools at their disposal, which is data. The number of options and superior solutions to issues and challenges increase as more information becomes available in the world. The need to keep this data organized and easily accessible is one of the significant demands brought on by these huge volumes of data. And if a company can't access the data and turn into a useful asset, then all the data that is produced in the world won't help it. And of course, most of the product-based companies' recruitment drives are designed to put the candidate's problem-solving abilities to the test. This is critical because the problems that such businesses face on a daily basis are quite large and complex, and they want to hire people who can complete this task in the shortest amount of time with the fewest resources. Advanced knowledge of data structures and algorithms is a clear indicator of a person's ability to solve complex problems in a short period of time. On that note, hey everyone, welcome to SimpliCode's YouTube channel. I hope you guys are doing good and staying safe. In today's session, we'll understand what are data structures and understand the fundamentals of data structures in this tutorial. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the latest tech content. And hit that bell icon to never miss an update from us. So without any further ado, let's get started with today's topic. Firstly, let us go through the agenda for today's session. We'll start the tutorial by understanding what is data structures, and then we'll go ahead and understand why do we need data structures, and after that we'll discuss various types of data structures that are used, and we'll conclude the session by understanding the importance of data structures and its applications in real life as well. I hope I made myself clear with the agenda, so without any further delay, let's get started with today's tutorial. So what is data structures? Now, firstly, let us understand what is data. Now, data is basically a collection of any discrete values that have any information, that conveys any information about any figures, facts, quantity, and etc. And when I talk about structure, a structure is basically organizing a data in a collective manner in order to understand quickly and process it to analyze the results in a more efficient manner. So data may be organized in many different ways of logical or mathematical models of a program, particularly an organizing data in its own way. So this organized data is nothing but a structure, and this organized collection of data is called as data structure. So data structures basically help you to understand how data is organized and how data flow is managed to increase efficiency of any process or program. And also it is the structural representation of any logical relationship between data elements. Generally say that this is like an ingredient you need to build in order to have an efficient algorithm. So these are the ways to arrange data so that they can be used efficiently in the main memory. So let us now move ahead and understand why we need data structures. So the purpose of data structure is to store the elements in an organized way to carry out a specific activity. Now most organizations collect and store data in an organized manner that does not facilitate any data use, and these various data structure types, and each type may be effective for some operations, but for some it might not. So it is the programmer's responsibility to understand which data structure is appropriate for efficiently analyzing the data so that it can be used to solve problems or achieve the goals. So data structure basically allows the user for efficient data search and retrieval patterns, and it also makes memory storage and brings quicker execution into picture, and finally it allows data to be stored differently as per the user need. So I hope you understood why we need data structure. Let us now move ahead and understand what are the different types of data structures that are present. Now, data structures are generally classified into two data types, which are primitive data structures and non-primitive data structures. Now, what do I mean by primitive? Primitive means basic. So, primitive data structures are the fundamental kind of data structures that only store data of one type. So, these primitive data structures are directly supported by any language, that is, any operation is directly performed in these data items. And some of the examples of primitive data structures are integers, character values, real numbers, float values, and double values. Now, on the other hand, we have non-primitive data structures. Non-primitive data structures are not defined by any programming language, but are instead created by the programmer. So it is a type of data structure that can store the data of more than one type with the help of primitive data structures. And non-primitive data structures are again classified into linear and non-linear data types. So when I say linear data structure, it basically maintains a linear relationship among the elements, which is known as a linear data pattern or a linear data structure. Now here the data is arranged in a linear fashion. And for example, array, list, stack, and queue are some of the examples of linear data structure. Next, we have the non-linear on the other hand. So non-linear data structure is a kind of data structure in which data elements are not arranged in a sequential order. There is a hierarchical relationship between individual data items present in that. And the insertion as well as the deletion of data is also not possible in a linear fashion. One of the best examples of non-linear data structures is graphs and trees. Now let us move ahead and understand each type of data structure in more detailed way. Firstly, let us understand what is an array data structure. Array in general refers to an orderly arrangement of data elements. Array is basically a type of data structure that stores data elements in adjacent locations, or you can say continuous memory locations. It is considered as a linear data structure that stores elements of same data types. Hence, it is also called as a linear homogeneous data structure. So when we declare any array, we can assign initial values to each of its elements by enclosing the values in a braces, that is flower brackets. So let's say I have an example here which is int a. I'm taking 5 elements, which is 10, 15, 20, 25 and 30. So if you look at, we have the first element, we have the value, and we have an address for that value that is present in the array. So the number of values inside braces should be equal to the number of elements that we declare for array inside the square brackets. Let's say I have like 10 elements, so it will start the address of the first element with the 0, next 1, 2, so on up to n values. So there are some limitations of array data structure also. It is a data structure which is of fixed size, and data elements are stored in a continuous memory locations which may not be always available, and insertion and deletion of elements can also be problematic because of shifting of elements from their positions. So let us now move ahead and understand the next data structure, which is linked list. Linked list basically store item collections in a linear order. So you can say a linked list is like a train where each bogie is connected with links. Now arrays are stored continuously in the memory when the given array size is large and the consecutive memory location is unavailable to store any other array elements. We cannot use an array in that case. So to overcome this problem, we have linked list where data can be stored at a random location and easily accessed, by which they are linked together. Now each element in a linked list contains a pointer or link to the next element in the list. So through linked list, insertion and deletion of data element is possible at all places of a linear list. And if you look at the diagram here, it represents a linked list with 4 nodes. Now each node has 2 parts. The left part in the node represents the information part, which contains an entire record of data items, and the right part represents the pointer, which points to the next node. Now the pointer of the last node contains a null pointer, and each node has an address to its name. So one of the main advantage of using linked list is it is easier to insert or delete data elements in any manner you want. And if I talk about a disadvantage of this type of data structure is it has a bit of slow search operation and requires more memory space. Let us now move ahead and discuss the next type of data structure, which is a stack data structure. Now a stack is a linear data structure in which insertion and deletion of elements are done at only one end, which is known as the top of the stack. Now stack is called as a last in and first out structure, which is in short LIFO, because the last element which is added to the stack is the first element which is deleted from the stack. So in a computer's memory, stacks can be implemented using arrays or linked list. So if you look at the schematic diagram which I have taken here, which has 5 elements, which is 10, 20, 30, 40, 50. Now here element 10, which is on the top, is the top of the stack, and element at the bottom, which is 50, is the bottom of the stack. Now elements are added to the stack from the top. Since it follows a LIFO pattern, which is the last in and first out, 50 cannot be deleted before 10 is deleted, and similarly 30 cannot be deleted before 40 is deleted, and so on. So I hope you understood what is the stack data structure. So the next data structure we have is queue. Now queue is a opposite of stack, which is a first in, first out. In short, which is a FIFO data structure in which the element that is inserted first is the first one to be taken out. So the element in a queue are added at one end called the rear and they're removed from the other end called the front. Now like stacks, queues can be implemented by using either arrays or linked list. And in a queue, the elements which are inserted at the back of the queue are enqueued. The elements are known as enqueued, and the elements that are removed from the front of the queue are called dequeued. So you can see in the diagram we have the element 50 which is at the rear end, which is an enqueue, and similarly which is the 10 element which is at the front of an array is a dequeue. So let us now move ahead and understand the next type of data structure, which is graphs. Now we have come to the non-linear type of data structures here. Now graph is a non-linear data structure where we have each data element is called a vertex and is connected to many other vertices through connections called edges. So it is made up of a finite number of nodes of vertices and the edges that connect to them. So a graph is considered as a mathematical structure which is composed of a set of vertices and a set of edges. Now if you look at the diagram here, we have 5 nodes which is 0, 1, 2, 3, 4 and various different edges of comprising of 0, 4 is an edge, 0, 1 is an edge, 4, 3 is an edge, 1, 3 is an edge and 1, 2 is an edge and 3, 2 is a combination of all these edges. Now there are various uses of graphs in real life applications also. It can be used for representing networks and routes in communication, transportation and travel application. It is also used in one of the most common daily applications, which is GPS, in order to find the routes to go to a certain place. And for mapping applications, again, it is used in e-commerce applications to present user preferences in a organized and systematic manner. Moving ahead, we have the next nonlinear data structure, which is a tree. Now, a tree is a nonlinear data structure in which data is organized in the form of branches in a hierarchical way of representing data, which is made up of nodes and connected by the edges. So the data elements in trees are arranged in a sorted order. It imposes a hierarchical structure on the data elements. So if you look at the diagram here, we have a total of 5 nodes and the root of the tree is called as the parent node and all the rest of them are called as the child node. So here the root node is 5 and the parent node is considered as 4 and it has 2 child nodes, which is 3 and 2. It provides a quick search, insert and delete operations, which is one of the most beneficial and the use case of tree data structures. And with that, we have come to the end of today's session, guys. Those were all of the data structures that we use generally in our, building models of different data types. Now let us understand the importance of data structures in real life. Now data structures make it simple for users to access and work with the data they require. Now for example, if you considered Spotify, if you want to listen if you want to create a playlist and if you want to basically add your songs in your own preferences, so it will automatically save in a sequential manner of your own choice, which is basically an use case of linked list where we are saving different songs in an sequential form. Data structure also facilitates greater processing speeds. Now, for example, let's say if you're trying to search for word or a name in a dictionary which starts with A, instead of searching each and every word, you can just switch on to the first letter, which A, and then search for the remaining letters, which is again an example of an array which is searching for locations in a sequential manner, which is basically another advantage of using data structure, which basically gives efficient data storage and scalability for the user. And finally, data structures are also reusable. And with that, we have come to the end of today's session. That was all about data structures, its various types, why we need to use them, and some of the important use cases that we can get from learning data structures. Now, this is the first video in the series of this data structure guide. So make sure you stay tuned to our channel SimpliCode for more videos on data structures, and wherein in our next video, we'll be covering about pointers, which is again a fundamental and foundational concept we have to learn before we proceed to learning different algorithms and perform operations on them. Thank you for watching the video, guys. If you found this tutorial informative and helpful, give it a thumbs up and share it with your friends and colleagues. If you have any further queries regarding any of the topics covered in today's session, feel free to let us know in the comment section below, and a team of experts will be more than happy to help resolve all your queries at the earliest. Until next time, stay safe and keep coding.